Hello. Let's look at this lesson. In this section, we actually build a DAG from scratch, building the knowledge graph from scratch. The knowledge graph, when we use RAG, very useful, can enhance its accuracy. And on the other hand, the knowledge graph itself, what about applications in various knowledge categories? Also very useful. Here we introduce large model service using IONET, building a knowledge graph from scratch. But this is a basic process. Can continue to optimize. Here we can use the large model. In one class, how to easily build a map. So just to recap. So let's start with this. The process of knowledge graph construction. In fact, in the era of small models, it's the same as the big model now. Mainly because there are differences in some links. You can take a look. The first one, directly data preparation. Needless to say, mainly some of these PDF documents, etc. Something like this might need some cleaning. The second one is called information extraction. Students who have done knowledge engineering, those who have done some artificial intelligence projects know. This information extraction, or knowledge extraction, is a very important part. Like the named entity recognition we did earlier, is a typical entity extraction. The entity is our people. Right place? Something like this. What about the second one? It's called relationship extraction. Determine what is the relationship between our entities. Previous practice. You need small models generally. Add some experts to build these things. The third is equivalent to a merger. We extracted a lot of entities, many relationships. How to make a network. Of course, this technology is also relatively mature. So this is just a few simple things that we can merge together. Of course, there are some specific algorithms. Then store it like a typical Neo4j. It's ready to use. There's another step we talked about above, which we call community discovery. Community discovery is actually the next step. Knowledge graph construction. It's a derivative. In fact, the most important thing for us to make a bigger model is to do. Using big models as knowledge graph. Here's the key part. Just this step. It's different when you do information extraction. Before, you need some of this kind of big data for training. In addition, experts are required to cooperate to build a relatively good entities and relationships. It's called triple extraction. But if we use large models, it can be very simple. Also write a prompt, and then using the big model itself, zero-shot capability, perform such an entity and relationship extraction. And I'm going to give you an example. Like we did earlier, this knowledge graph project, especially some vertical ones, it requires a lot of data. You need to do it manually. Expert interpretation. It may take a few months to build a usable knowledge graph. But we use large models. If the computing power is sufficient, maybe tens of minutes, it can build a relatively complete knowledge graph. You can take a look. How do we do it with this big model? We did use large models. One of its fundamental principles. Chat is anything. All the work is done through prompt. Take a look at how this prompt is made. The function of this prompt is to extract triples. Draw a head like mine is an entity. Tail is an entity. Are two entities. Then the relation. Just extract these content. Just such a prompt will do. Then import our documents. Let's take a look. This is our document. Put it here. So that's our prompt. Of course, there are also some requirements. How to extract the entity first. How to draw the relationship, write it clearly. It's such a simple prompt. Is the key to our knowledge graph. We parse it in PDF. This function simply read the PDF. Convert to text. Such a text. This is a prompt. It's like giving the entire PDF to the big model. Take a look at this PDF document of it. It's over 20 pages long. Read text. Embedded in this. Then throw it to the big model together for processing. Take a look at the first part of the prompt. What if it is not installed? Then install these components. So that's our whole prompt, the first part of it. Type out the first 300 characters. Let's take a look. Start calling the big model. We use the large model of Qianwen. Of course, it can be exchanged. This is one of our most common calls. We read the message, then parse. Everybody pay attention, because this text is very, very long. So this one may be slower. If the document is too long, exceed. The token of a large model is limited. This document can be divided into multiple parts. Each copy extracts a set of relationships. Just merge multiple sets of relationships. Of course, you may have to run a few more times. The result of it running out, probably nonsense, because the big model is inherently random. This is a problem we often encounter. That is, you let it enter a Purgeson string. It tends to have a few quotation marks around it. If there is no result for a long time, because there are more strings, you can try again. And then it's a little bit easier. This is actually a network library. Put all our relationships in it. It is the triple obtained earlier. Add entity here. This is Edge. In that case, he can automatically form a network of relationships. Then do the basic. Such a community extraction. Just such a process. Let's take a look. This is a graph. This is a more commonly used knowledge graph extraction process. This is to form a multi-level community, mainly generating and associating community IDs. For us, mainly the first few steps. It's okay to add edges and nodes. Reforming the community. We can use more complex algorithms to make these things. So here's some basic algorithms. We type it out. How many sides are there? Can output both. Naturally longer. How many sides? How many such nodes? This is what we extracted. A basic knowledge graph. We can visualize this knowledge graph. You can take a look. Just use this plot to draw. It's not very clear. It can be plotted using a specialized network library. Draw it in such a form. Because NX is specialized in drawing dynamic network diagrams. Simpler and clearer than above. Go one step further. We can put it in the Neo4j database. Save the relationship like the previous one. This can be saved. Of course, it's easier. I can draw it into a web page. Let's take a look. Also relatively simple. It's one of them. To form such a network, then generate a web page, and you can take a look at the page. This is much clearer. Let's take a look. Because of this dynamic, this is DeepSeek. This is 0. This is the relationship between them. Students familiar with the DeepSeek framework, you can see that this is still relatively accurate. There are isolated dots on it. That's all, thanks.